Welcome to the laboratory on the identification of a hydrocarbon. If you've made it to this point, guess what, folks? You've already sat through the pre-lab videos and you know what to expect. So let's get right to it, shall we? So in this laboratory experiment, we are given an unknown liquid solution. And it's going to be up to us to figure out what that unknown is going to be. Now, I'm going to go ahead and give you a trick. If this was really me and I had no lab experiment to go by, I would take this unknown liquid and I will take it to our infrared spectrometer that we call IR. I will put a few drops on the IR instrument, and folks, it's going to tell me exactly what it is. That's how easy this will be. However, we just can't use one test in order for us to determine what the compound is. We need proof. We need evidence. And it's often going to require more than just one type of test. And that's the purpose of this experiment. So here's my unknown liquid. My unknown liquid was labeled with a G. All right, so we have unknown G here. And I need to go through and I need to figure out what this unknown liquid's going to be based on the table that they give me in the lab procedure. So the very first test that I decide to do is something called the refractive index. The refractive index is a value, it's a fingerprint that I can use to help identify a compound, just like melting point and just like boiling point, just like density. And we get the refractive index from an instrument, and that instrument is called the refractometer. All right, so right here in the picture to the left is a refractometer. Now, this is old school, okay? We're talking about the 1970s, give or take a little bit here, folks. So this piece of equipment has been around for quite some time. We have about 6 or 7 of them in our lab. Refractive index is also something that they should provide you in general chemistry, as it's one of these kind of basic, when you begin to talk about physical and chemical characteristics and physical and chemical properties, refractive index is involved in that whole conversation. And you should have used a refractive index in general chemistry, but there's a chance that you probably didn't. Depending on where you took it, depending on who you had, depending on what equipment that they had in the lab, there is a possibility that you have never seen refractive index before. So this is an RI. We abbreviated RI, of course, for refractive index. And it looks like I'm using RI number 3. So this is the instrument that I am using to make my measurements with. Sometimes that's very important. Sometimes I have to kind of note that on a data sheet or in a laboratory notebook if I'm writing one up. A couple of things about the refractive index I want to talk to you about. All right, so first, there's a couple of pieces and parts that we're going to have to get acquainted with. And I want you to take a look at this center area right here, because this is where all the magic happens, okay? So the first thing I'm going to do is open that up. All right, so see the lamp? This is the lamp down here at the bottom. I have just pulled the lamp down toward the countertop. And it's on a hinge, so I'm perfectly able to do that without a problem. And then I'm going to open up this area here, which is what we call the prism. And the prism is going to be where I'm going to put my sample eventually, okay? So this provides me the surface. I'm going to put a few drops of my sample on that surface. I'm going to close the prism back up, and then I'm going to raise the lamp back up when I get ready to read. So a couple of things are going to have to happen here, okay? When I do put a few drops of liquid on the surface of that prism and I close this back and I raise the lamp back up, there's going to be some adjustment. This is not an automated instrument. The new refractometers are automated. I just literally put 1 or 2 drops on the surface and I hit run and it tells me the number. I don't have to worry about it. But these are more manual. These are more old school. So that means I'm going to have to make the adjustments. I'm going to have to kind of fine-tune this instrument in order to figure out which hydrocarbon that I have from the table. So on the side of the instrument, big fat knob over here to the right-hand side. This is a manual adjuster. And it's going to adjust what we call the dividing line of the viewfinder. So this is what's going to happen, folks. When you put a sample on the refractometer and you look through the eyepiece is going to be right up here at the top. You can see that. It looks like a microscope, right? When you do this, you're going to look through the eyepiece, and there is a chance that you will see a dark half and a lighter half. And it's going to be up to me because there's going to be some crosshairs that are here, right? And it's going to look like this, maybe somewhat in the center. My drawing's kind of off. But it's going to be up to me to lower and raise that dark and light half until it really does get on the center. I mean, that's really what I'm after right there. So this is the knob that does it. It is my main adjustment tool. And you'll see that when I show you an image of the viewfinder in just a minute. Over to the left-hand side, we have a flip switch. And the flip switch, number one, flips the lamp on. And then the flip switch, once the lamp comes on, once I line up the dark and light half, I'll flip the switch down, and then I'll look through the eyepiece, and a meter will appear, a magic little meter, for me to write down my value. Something else that I also want to mention is this dial on the front. This is a fine adjustment tool, all right? So fine adjustment. Sometimes people's eyeballs work a different way, and when you look through the eyepiece, things might be out of focus. If they're out of focus, then that's the purpose of the fine adjustment tool. So you've already lined up the light half with the dark half. That's pretty easy to see, but that dividing line might be a little fuzzy to you. And if it is, then you need to dial that meter either to the left or to the right, and you will see that dividing line get very, very sharp. And that's what you want to see. You want to see a sharp dividing line, nothing fuzzy, nothing smeary. So if it does show up that way through the eyepiece, that's the purpose of the front dial. So the main adjustment dial to the right, the flip switch to the left, and the fine adjustment tool on the front. And folks, that's all there is to using a refractometer. All right, so what you're going to see here is a video of me going through these pieces and parts again, but I'm doing it live. So that way you can actually watch me as I demonstrate and explain it. So what you're looking at here is our refractive index, or our refractometer. Let me tell you how to use it. So here in the front is our sodium D lamp, which is what makes this work. I'm going to lower this down just so I can get it away from the prism. The prism's here. The prism will open up, and I will put 1 or 2 drops of my sample onto this prism surface right here. I want to make sure that it's clean, so I want to clean it with acetone or methanol before I use it. Once 1 or 2 drops of liquid goes onto the prism, I will then close this cage back. I will raise the lamp back up on the refractive index instrument, and over here to the left, I'm going to see a flip switch. The first position will turn the lamp on. I'll then look through the eyepiece to look for a very dark and light half, and I'll line it up in the middle. When I line that up into the middle, I'm then going to go back to the flip switch, and I'm going to hold it down, and that will allow the meter to show up on the refractive index instrument. If I need to adjust the light half and the dark half to get it in the middle, then over here to the side, I'll see a huge knob, and I'll just turn this left or right. And when I do that, that will raise or lower that divider half, so that way I can line it up the perfect way. All right, folks, so refractive index is pretty easy to use. I mean, there's nothing really more to it than that. So no one said that chemistry had to be hard. No one said organic chemistry had to be hard. No one said instrumentation had to be difficult to use. Very simple. A child can do it. All right, so here I just took a disposable pipette, and I sucked up some sample into that plastic pipette, and I put 1 or 2 drops on the surface of the cleaned prism that I have cleaned with acetone or that I've cleaned with methanol. All right, so 1 or 2 drops go on, and then I'll close the prism back, so there's a close-up of me closing it up, and then I'll raise the lamp back up to that prism area so our light can start going into the prism and going through our sample. So then I look through the eyepiece, and this is what I see through the eyepiece. Okay, so it's kind of off center. I apologize for that, but I think that you can still see the majority of the view that you need to see, because we have a set of crosshairs on here, don't we? I mean, we see this. Look, there's a line, and here's a line, and it makes an X, and X marks the spot. Pretend like you're pirates. So it's going to be my job, because I clearly see the light area up here, and I clearly see the dark area down here. So it's going to be my job to raise or lower that dividing line. And I can see that dividing line. It's right there, and it's pretty clear. It's pretty sharp to me. It's not too fuzzy, right? So I need to take that big fat knob over to the right-hand side, and I need to either raise it or I need to lower it. And in this particular case, I need to lower that dark line to the crosshairs. And that crosshair is right there, folks. So this needs to go down. So I'm going to take the big fat knob over to the right-hand side, and I'm going to turn it in one direction to lower it, and then I'm going to lower it down until I get to the crosshairs. And there we go. That's where that's at. Now I feel pretty good about what I see. All right, I see the dividing line, light half, dark half, right there in the center of the X. It looks pretty clear. I mean, I see some fuzzy over here to the sides, but that's not a big deal. I'll see some orangey red color here and some blue color there. But here in the center, it's pretty distinct. So I feel good about the view. I feel good about the setting. No more adjustment is made. So I'll go back to the flipper switch to the left-hand side, and I'll hold the flip switch down. And when I hold the flip switch down, this is what I see in the view. This is how you use a refractive index, folks. That's all there is to it. So I'm going to let you write down the number that you think this value readout is supposed to be. Here's a couple of things about the meter. Here's the crosshair, right? And you can see this big line that goes straight up. All right, so that's the line that I'm going to read, folks. This one right here. So that means in order to properly provide a refractive index, I'm going to have 4 decimal places, 1, 2, 3, and 4. And I get those 4 decimal places from wherever the meter crosses that vertical line right there. The way that this meter is divided up, this is 420, right? Right there is 420. And this is 430. So now we've got to think about divisions. Well, that means that this is 421, 422, 423, 424, 425, smack dab in the middle. It's the taller line. 426, 427, 428, 429, and 430. That is how the divisions are made in the refractive index that we have. However, you also see these short little tick marks. These are kind of halves. So for instance, let's say that my readout was right here, smack dab on that line. What would be my readout for this value? Well, this is going to be 1.42 something, right? Because I don't get to 4.3 until here. So this is 4.2 something. Well, that's 4.21, 4.22, and this is 4.225. And then 4.23, 4.235, 4.24, 4.245, 4.25. So you should always report 4 decimal places for your refractive index. So hopefully you can pause this video, maybe take a look at this meter. Let me go through and erase some of the markings so that maybe you can see that a little bit better, and then report your readout that you get for your refractive index. All right. So our first test is done. Do you see how easy and simple that was? Folks, it just took me 15 minutes into the video, and I'm already completing one of the tests that we need to do. And quite honestly, if I did this in person, it would take me about the same amount of time. It's a very easy test. It's a very quick test. There should be no excuse that we shouldn't do this test whenever needed, because everything is convenient, everything's super quick, and it's a very easy method in order to master. So here is the refractive index for my unknown, and this is clue number 1. Imagine that you're playing Clue, the game. Do you remember that board game? I do. Maybe I'm showing my age, but here's clue 1. Now we need 2 more clues in order to figure out who did it. All right, so before I get finished with my refractive index, I'm going to go to my chem wipe. A chem wipe, think of it as a tissue that you would maybe clean your glasses and stuff with. It's a very smooth surface. We don't want to use any paper towels on the refractive index and the prism because that could scratch it or damage it, and chem wipe is always the thing to go to for these. So I'm going to take a wad of chem wipes. I'm going to take some of our acetone that we have in our laboratory into a nice convenient squirt bottle. I'm going to squirt some acetone onto some of the chem wipes, and then I'm going to wipe down the prism, and then that way it's going to be ready for the next person that needs to use it. All right, so there's the story with refractive index, and I'm sticking to it, and I'll tell you a little bit more about what we need to do with that refractive index value at the end of this presentation. All right, so there's test number 1 now finished. So test number 2, density. We need the density of this hydrocarbon. And we're going to do this. We could have used a manual pipette, but I've decided to use a micropipetter instead. So I've got a video here that basically shows you how to use a micropipetter the proper way. And it explains a couple of things about the micropipetter for you in case you have never used one of these before. So sit back, enjoy the show, and I'll be right back. What we have here is a micropipetter and micropipetter tips. The micropipetter that I chose, let me zoom in and get this kind of closer for you, is a 100 to 1,000 microliter. We call it micropipette because it delivers microliters and not milliliters. So you need to understand that 1,000 microliters is 1 milliliter. This makes my density measurement super easy. If I can just dial this up to 1,000, which represents 1 mil, and deliver that amount to a balance to get a mass, then that divided by 1, because of 1 mil, is going to give me the density. All right, so the way that I do this, up here at the very top, I'm going to see a meter. There's only 3 digits though, and 1,000 is 4. So the way that we read this, 100, the other 0 is that small little tick mark that's down there at the bottom. So that does represent 1,000. To use the micropipetter, I need a micropipette tip. So again, let me zoom back in for you. I'll just take my micropipetter. I do not have to touch the tip. I just push it down onto the top, and I lift this up, and there is the micropipette tip on the bottom. All right, up here at the very top of the micropipetters, there's a plunger. This plunger, if I push it down, I'll get to a first point of resistance. This creates the air pocket, so that way I can take the tip, put it into solution, and slowly let up on the plunger tip. And this will fill 1 milliliter or 1,000 microliters into my micropipette. Okay, folks, so that's the first step that you need to be able to do when you use a micropipetter. And I'm going to be honest with you, I have seen people go crazy with these things. I mean, it's almost like I have handed them a live snake to handle in a laboratory. You know, they don't know how to use it. They're using it the wrong way. I specifically tell them, listen, you need to put it into the micropipetter container, the micropipette container, and pull out your tips that way. And you should see them, they grab the tips and they try to put the tips on by hand. And I'm like, no, you just did not listen to me. The micropipetter is made so you can sit right down on top of the tip and pull them up as you need them. You do not need to pull them out by hand. What are you doing? It's almost like they don't pay attention at all. They probably don't, but that's okay, whatever. The other thing is that they see 1,000 and they try to dial this up to 1,000. And then they come back to me and they say, well, wait a minute, this only goes to 100. I'm like, no, you just didn't pay attention to me again. It goes to 1,000, but there's only room for 3 numbers. So 1, 0, 0, and then that small tick mark down below is the 4th or digit, which is another 0. So this really represents a 1,000. Not all micropipetter tips are represented that way. It's just the way that ours has been constructed and manufactured. In addition to that, they are student use micropipetters. They are not what we would call analytical grade micropipetters that would be used for a company. So what if I get this micropipetter and what if it's not set at the proper value that I need? So for instance, let's say we need it 900 microliters, not 1,000. How do we adjust that dial? How do we adjust the micropipetter in order to give me 900 microliters or 0.9 milliliter? Well, you got to keep in mind, this represents 4 digits. So this needs to say 0, 9, 0, and then that tick mark has to say another 0. So 090 is 900, not 90, and that's again another confusing part about the micropipetters that we have. Over here to the side, up here at the top, you're going to see a dial. This dial can be turned, and that is what will adjust the numbers that you see on the micropipetter. So this is how we adjust for the volumes that we actually need to be pipetting. All right, so I'm going to put my thumb up on the plunger. This is the proper way that you hold a micropipetter. So that little kind of curvature piece up there nestles perfectly on your finger. It's like a little hanger, and it hangs off of your finger just like your clothes hang off of your hangers in your closet. At least I hope you hang up your clothes and not just trash them all in the floor. So I'm going to push that down to the very first stop. That's the first point of resistance. Then I'm going to stick the tip into the solution, and then I'm going to slowly release the plunger. And again, that's something that people do not do. They just pop it right off. And every time I see somebody do that, I just cringe, because this can ruin a micropipetter. It can shoot your liquid up into the tip. That liquid can go up into the mechanics of the micropipetter, and if that organic starts to react with the gears and all of the other things that's inside of the micropipetter, you have just now ruined a $400, $500, $600 micropipetter because you did not listen to me and go slow with releasing that plunger. All right, so here's another video I'd like for you to watch, and it's me sucking up and dispensing maybe a liquid using the micropipetter. Guys, what you're seeing right here is the micropipette tip, and it's filled with liquid. It's really nothing here more than water, just for demonstration purposes. But you can see the liquid level that's right up here at the top. So this is 1,000 microliters, and that line is a very good sign that it did suck up the proper way. It gives me a very good judgment call on whether or not I used the micropipetter tip properly. Here at the very top, I told you that we have to go all the way back down to the first plunger stop. That will deliver most of the liquid out of the micropipetter tip, but there still will be some residual that will be left over. So in order to get that residual out, I'm just going to push it down even further than that first plunger stop. And that creates a little poof of air that goes out of the tip, and it forces everything out of the micropipette tip. All right, so I'm going to push down to the first plunger stop, and then there goes my puff of air, and everything is out of the tip, I hope. All right, so that's the way that we're going to do the density, and that's the way we're going to use the micropipetter tip for my unknown alkane. Okay, so you're probably asking why micropipetters. As you can imagine, the more you use these, the more comfortable that you're going to get with them, and it makes it very quick to deliver volumes versus an old-fashioned glass volumetric pipette. Don't get me wrong, we still use those. We use those all the time. But if I just need something very quick and convenient, just maybe one time only kind of thing, folks, a micropipetter is the way to go almost every single time in a lab. So I'm going to go over to my balance, and I'm going to tear the balance out, and I'll get my balance to read 0.0000. I'll then put the micropipette tip into my unknown solution, as you can see here, and then I'll slowly suck up 1 milliliter of solution using the micropipetter. I'm then going to dispense that into the container that I teared out before, prior to this, and then this readout is the density value for my unknown, because this represents the gram for that 1 milliliter that I dispensed. And folks, grams over mil. Grams divided by milliliter is density. So grams divided by 1 milliliter, that's the gram value that I'm seeing there. So that means that's also the density value as well. All right, so test number 2 is already done. Look how fast that was. I mean, that took me like 10 minutes to describe, and it took less than that to actually do when I was in the laboratory. All right, so my final test now is going to be my boiling point. And we're going to deviate a little bit from what the laboratory procedure is going to tell you to do with boiling point. They want you to do a simple pot distillation, and I just don't feel comfortable with that, right? So there's a simpler way to do boiling point. That's all that we need for this lab. Nothing major, no big deal, and that's using something called a Thiele tube. So we need to show you a Thiele tube. I need to show you a Thiele tube. Why do I start to talk to myself like plural? That's kind of like a sign of crazy, isn't it? Well, maybe so. If the shoe fits, I guess I'll wear it. All right, so here's a Thiele tube. And the Thiele tube is just basically a piece of glassware that has this elbow on it. And this Thiele tube is filled with mineral oil. And what you see here is a test tube, a smaller test tube, that I have submerged down into the Thiele tube with that mineral oil. Okay, now at this point, that test tube is empty. I need to put my solution that I want to measure, boiling point wise, into that test tube. I do not put anything in the Thiele tube except for the test tube. All right, so this Thiele tube should stay nothing but mineral oil. If I begin to put my sample down into the Thiele tube, and I've seen people do this before too, for goodness sakes, they almost catch the lab on fire. That's bad news, right? So test tube only goes into the Thiele tube. And then I'll put my sample in the test tube, not the Thiele tube. All right, so in order for this to work, I also need those capillary tubes. These were the capillary tubes that we use in our melting point stations, whether it's the Vernier melting point or the MP50 melting point that we use in our lab. You know, the capillary tubes that are open on one end but closed on the other. I do not want TLC tubes. I don't want those types of capillary tubes because those are open on both sides. They need to suck liquid up. That's not what we need here. We need the closed melting point capillary tubes. It's very important. Otherwise, this thing's not going to work for me. All right. Next, I'll need a thermometer. It's somewhat out of focus, but I do need a thermometer so that way I can record my temperature at which this substance boils, of course, right? So I'll pull a thermometer out of a drawer, and then I'll take one of the capillary tubes out. Notice up here at the very top, this is where my curved closed end is at. That's the way that I'm holding it. And then down here at the bottom, you can't see it in the picture, but that will be my open end. And I need to put that capillary tube in the test tube. And that's the way that I need to put it in there. The closed end needs to be pointed up. So in other words, I need to put that capillary tube in almost upside down than what we would put it into a melting point. So closed end points up. And then I've also put my thermometer into that test tube as well. And my liquid is eventually going to go into the test tube in addition to these two things. And then we begin to heat the Thiele tube. That's how this process works. All right, so before we go further, I've got a video of the Thiele tube I'd just like to show you before I move on. Guys, what you're seeing in this video is the Thiele tube. It is a much simpler way to do boiling point than how the lab directions tell me to do it. So if there's an easier way, why not do it that way? So the Thiele tube, the way that this is made, this is filled with mineral oil. And this mineral oil is going to get heated with a Bunsen burner. I'm going to typically heat it at the bottom, and this oil will circulate throughout the Thiele tube. On the inside of the Thiele tube, you might not be able to see it from this distance, but there is a test tube, a very small test tube here, and that test tube has a thermometer and a capillary on the inside.
All right, so there's my fancy Thiele tube. We spent about $50, $60 on a Thiele tube to bring it into our laboratory so that way we can make your life convenient. See how we always look out for your academic success. All right, so here's a close-up picture of me dispensing some of that unknown liquid into the test tube that has my upside-down capillary tube. You can see my upside-down capillary tube right there, and my thermometer as well. All right, well, how much liquid do I need to put in? Notice the position here, folks. My test tube stops right here, and the test tube is at this elbow joint. Okay, so that's where I want the bottom of my test tube to be located. Okay, that's the perfect position for that. Additionally, if I take a look at my thermometer bulb, I really like to cover the bulb up as much as possible. Now, sometimes we don't have that much liquid in order to do that. It causes us some problems sometimes, but that's okay, whatever. The other thing is that this thermometer has an immersion line, and I am very far away from the immersion line, folks. That immersion line is the proper level that my liquid should be in, or my liquid should reach, in order for my thermometer to report an accurate reading. So if we get a boiling point that's slightly off, then this could be one of the reasons. I'm not at the immersion line of the thermometer, and that could be a problem. All right, so here's another video. As you can tell, my sample is in that test tube, as well as my capillary and my thermometer. And this video just kind of shows you close up how this setup is going to start working.
So I think this is a better close-up view of what's happening at the arm of the Thiele tube. And here you can maybe see the test tube that is submerged in the mineral oil of the Thiele tube apparatus. This test tube again has about 5 milliliters of my unknown here at the very bottom. It also has the upside down capillary that will create bubbles throughout this process. When those bubbles happen, I take the heat away and I watch for the last bubble. And then this thermometer will provide me the temperature at which that last bubble has happened. And that is my boiling point, folks. So something as simple as this, just the Bunsen burner, and that's it. Anybody can do it, even your granny.
Okay, so once again, a very simple test, just like density, just like refractive index, not a problem here. And it's bubbles. Bubbles are where it's at. So I need to start heating this Thiele tube up. And the way that I'll do this is with a Bunsen burner. So here, we're going to light it up.
Okay, it's time to light this sucker up, and we're going to heat this mineral oil so that way we can get a boiling point for that compound. So what you see here in the front is a Bunsen burner. I'm going to turn the gas on so that way we can light a fire. So there we go. And I'm just going to hold the Bunsen burner. Look at this. I can swing this around and do whatever I want to do with it. But I'm just going to heat the bottom of the Thiele tube right in here at the elbow. That way I can concentrate the heat at the bottom. It will circulate on its own. And then I'm looking for bubbles that are going to happen right in here. So when I get to that point, I'll come back and I'll show you what that looks like. So that way you'll know how to read the boiling point with a Thiele tube.
Folks, that's all there is to lighting up a Bunsen burner. I hope that you've at least lit up a Bunsen burner. Maybe you've not, especially if you've taken an online general chemistry course. But if you've had the pleasure of being in a general chemistry lab, I have a very good feeling that you have used a Bunsen burner before. All right, so I'm going to take this Bunsen burner and I'm going to only heat the bottom and the bottom elbow. This is the only area that I will hit with the flame of the Bunsen burner, and then I'll keep an eye out on the test tube. And at the test tube, I will start to see bubbles that will appear when I get closer to the boiling point, or actually when I have surpassed the boiling point. So the capillary tube, that's its purpose. That's why we put it upside down. We create almost like an air pocket. So when that temperature begins to boil, the bubbles will come from the capillary tube, and I will start to see a stream of them that will come out very, very fast. This means I'm surpassing the boiling point. I've already went too far, and I need to cool this sucker back down so that way I can get closer to the actual start of when the boiling happened. So in this video, you're going to see those stream of bubbles. Okay, so you're starting to see the bubbles happen pretty vigorously at this point. I'm going to take the heat away, and I'm going to sit here and watch for that very last bubble to come out of that capillary tube. I'm getting closer and closer to the boiling point. That's what basically that means. However, my thermometer always lags. All right, so as I was saying in the video, the thermometer always lags, folks. So you're going to see these bubbles. When you see these bubbles, we're clearly past the boiling point because it's boiling. But my thermometer takes a little bit of time in order to get up to the temperature at which it should be at. So this is the reason that we say take the heat away when it begins to bubble like this. And record that temperature down. Record that what you see. So here is the thermometer. And here is the temperature at which the tremendous amount of bubbles started coming from that capillary tube. Now, that's not really our boiling point, but that is a temperature that I would like to write down to at least keep track of, okay? So you can read that thermometer just like I can, and you can make your observations and you can make your data decision, okay? So now I'm going to take the heat away, and I'm going to let this solution cool, and I'm going to keep an eye out on that capillary tube. So my bubbles are slowing down, as you can see here, and I'm getting closer to that very last bubble. So we'll just continue to wait and wait until that happens, and then I'll read the temperature on the thermometer. Okay, so one of the things that you noticed in that video is that my stuff did boil away. Some of it did, right? I mean, in the beginning, I had enough liquid in here to cover the bulb of the thermometer up at least. But throughout this process, because I hit it with some heat, that turned into a vapor and it escaped my test tube. All right, so I don't have as much, but it's still in there. The capillary's still submerged. I know it's not ideal for this thermometer, but I'm going to continue to wait until I see the very last bubble. So here in this image, the bubbles were slowing down. You saw that in the video, right? So I'm going to make another temperature recording. And this is the temperature of the thermometer, but I was still getting bubbles at this point. They've slowed down, but I'm still getting them. But I'm getting closer to my boiling point. All right, so finally, we need to watch for that very last bubble. At this point, my bubbles tremendously, they've slowed down. As you can tell, they're starting to come out of the capillary slower and slower. And I'm getting another one, slower. And it looks like this or that last one was the last bubble that we caught on camera together. All right, so now at this point, I'm going to read my thermometer and see what temperature this happened at. Good for us. Look at what we did. As you can tell in that video toward the end, it was starting to suck air back up into the capillary tube, and that's pretty normal. That is what begins to happen toward that boiling point, and that's why the bubbling begins to stop from the capillary. So in this image, this is the temperature at which that very last bubble happened. So 3 temperature recordings is what we've made. One when we got stream of bubbles, 2 when the bubbles slowed down significantly from before, and 3 the temperature of the very last bubble. And I can use all 3 of those to maybe help me make my decision on which identity this unknown is going to be. All right, so now let's kind of wrap this all up. We had a density value, and there's no correction that's going to be needed on the density value. Whatever you get on the balance, folks, that's the density that we're going to report because we distributed 1 milliliter into that container. As far as the boiling point, there's no correction needed for that either. The lab directions are going to tell you, you need to correct for the boiling point if the torr is below 750. Well, even if you did correct it, it's only going to change it slightly. It's not a big major change that goes on. But we were not below 750. The barometer readout for the room that day was 764. So no correction is going to be needed at all. Nothing. All right? Normally we are 1 ATM because we're at sea level. ATM is 760 torr, and this is normally where we hang out. So only if it's below 750 do they tell you to correct for it, and we are nowhere near 750 for this procedure. So no correction needed for boiling point either. However, there is a correction for refractive index. Okay? So the correction for refractive index involves temperature. Refractive index is very temperature dependent. So in the textbook, you are going to see refractive index reads that are basically at 20 degrees. This is what they would refer to as room temperature, even though room temperature is never really 20. It's always like 23, 24 for us. So we need to go through and we do need to correct for refractive index because this is not the ideal temperature that they have reported refractive index for. So this is a very simple process to do. I'll take the T, which is my temperature, and I'll plug in the room temperature of which I made my measurement. And that's going to be 23. 23 degrees was the temperature at the refractive index when I did my measurement. So I'm going to take 23 minus 20, and I'll get a number. Then I'll multiply that by 0.00045, and I'll get a number. Now, that number could be negative, that number could be positive. That really depends on the room temperature that you have, that you've made your measurement with. Typically, we're always higher than 20. So if we're always higher than 20, then this will typically always be a positive number that we get from the equation. But if my temperature of my room was 19 or 18 because I liked it super cold, or we live in Alaska, then this number is going to go negative in here, which means that this total value will become negative at the end, and that means we will have a negative number from this calculation. We keep that negative if that what goes on, but it's not going to go on here because we've got 23. So once I get this number, I'm then going to add it. Look here at this very last statement. You take that number and you add it to the refractive index that you got from your instrument. That's how we correct refractive index, folks. All right? So plug your temperature into this equation. Solve that first. Then multiply by the factor 0.00045. You'll get a value. And you'll take that number and you'll add that number onto the refractive index that you read from that meter. And that's how we correct it. Okay, so that's all there is to this refractive index, boiling point, and density lab. Nothing more than that, folks. It's a simple, easy peasy. You can't ask for any better. If you were actually doing this in a 3-hour time block, which is normally what labs are, you would probably have this done in less than an hour. And then you would be happy and you'd be like, yay, I get to go home. And I would say, yeah, have fun. I'll see you next time. So that is the ID of the hydrocarbon, a virtual lab. All right, so use those 3 values that you've now discovered when we did the lab together, and then compare those values to the table that's in the lab procedure, and you tell me, out of those possible choices, which alkane, hydrocarbon, which of these hydrocarbons did I pull out and put into this bottle? I hope that you can identify it the correct way. Until next time, bye-bye.